do so. But if we can stay on as much as possible, that'd be great. So we're going to talk about birds and mammals tonight as a component to the forest system that y'all have talked about. And we like to combine these because those are two of groups of fauna prevalent in the forest, as well as all the other systems as well. But this is where we group them. So I'll spend about an hour talking a little bit about birds, and then Nick Griffin with the Texas Parks and Wildlife, he'll talk a little bit about mammals. So in our time here, we're going to talk about just I call it the technical world of birds. We'll talk a little bit about migration, why birds are important, because that's the whole point of this. I can sit here and tell you about identification and those things like that, but what does that mean? Well, why are they important? Why study and why know more about them? That's the take-home message, and we're going to be talking a little bit about that tonight as well. So I'm going to go ahead and share my screen and start some slides, and then we'll go through those. There we go. Let me know if y'all see that. Y'all see that?
Yes.
Excellent. So I lovingly this presentation bird brains, okay? Because birds are very smart, and boy, we can go in a different direction when it comes to birds. So let's go ahead and get started. Now, real quickly, my fascination with birds started very young. I was probably second, third grade. I remember there was a program in schools, and many of you teachers are out there, probably understand this or know about it, and everybody probably, called RIF, Reading is Fun. And we got a free book every year, and none of my friends liked to read, but I did. So they gave me all their books. I would get all these nature books, and I'd always get these bird books. And I so enraptured with birds. And in my backyard, I knew birds that were in our backyard. So let's test your knowledge. What do we have here?
Blue jay.
Blue jay, exactly. All right, they're only going to get harder, guys. No, I'm kidding. They're not going to get very much harder. So we got the blue jay. So I knew what the blue jay is. I saw it in my backyard. I'd see this bird.
Crow. American crow.
Right, American crow. I bird, and then I see these.
Cardinals. Cardinals. Male and female.
Look at you. So, that's right. So a male and female cardinal, male to the left, female to the right, and what we refer to as sexual dimorphism, ability to see the different sexes based on color, showing off his attractive mate, females drab color so that she can blend in as she's nesting. So these birds were easy. But then, y'all know what this is?
Loon.
Green heron.
That's right, crickets. And I expected y'all to be quiet because I didn't know what this bird is. It's not found in the US. It's actually in Africa. It's called a hammercock. Now, funny story. I did this class 3 years ago, and there's a gentleman by the name, if anyone knows him, his name is Charlie Amos. He actually used to do the birding. He usually does the birding program. And I put this picture up expecting no one to know what it was. Of course, like 2 seconds, Charlie goes, hammercock. I'm like, oh, great. Of course you would know. Totally just got what I was trying to prove. But sometimes we birds that we don't know. And we have to look things up. This is the bird that got me confused. You probably know what it is because you're adults. I was a kid, so lay off, right? What bird is this?
Cedar waxwing.
Cedar, where were you 40 years ago or whatever? So waxwing. I saw this bird and I'm like, what is that? So I was able to get my bird book out and I just flipped through the pages and finally found it. And then I was hooked because it was fun now. It was like an investigation, if you will. I'm trying to figure out what this bird is and what's it doing in my backyard in Central Texas.
Michael, they're funny when they're drunk.
What in the world? So bird, and that story it's that bird. Can someone, is that on mute or I hear some talking? So anyway, this bird here got me into birding. Now, anybody of y'all really into birding? How many birders are out there? Who just like see birds? Okay, I see, okay. Some hands come up. Anybody want to share real quickly, is there a particular bird that really got you in and just kind of drew you into birding? Anybody?
I'm not, oh,
Falcon.
Falcon, okay. Those are cool.
It didn't get me into birding, but the one bird that I love is the Mississippi kite. The way it flies, and the coloration, just a gorgeous bird.
Oh,
Beautiful.
Beautiful bird. And that's a bird that's expanding its range. It's spending more time here in North Texas, and being more prolific. And a lot of people, I get calls all the time. I see this gray hawk, and they describe, and I say, look up Mississippi kite, and they kind of laugh at me a little bit, like, you sure? Try it. And they do. Oh, you're right. It's a Mississippi kite. So yes, that's a cool bird.
The most exciting bird I ever saw for the first time was the roseate spoonbill.
Oh, those are gorgeous. Roseate spoonbills are so gorgeous. That's a good one, Joan.
I have a ton of mockingbirds that I like to watch. They like to fight in my front yard. So that's gotten me interested in birds.
Fun. Michael, if there was a choice between raptor and songbird,
Cool.
scissor-tail flycatcher is awesome.
Yes, scissor-tail flycatchers are an awesome bird to watch. So y'all are naming some really cool ones, So when we think about birds, I just asked you what were some of your favorite birds, but not everybody's on board with birds. There are different views of birds. You got individuals who encounter this and like, I don't like birds. And I remember my late father one day, I just washed my car and a couple birds just pooped on my car. He looked at me and chuckled and said, hey son, you like birds now? I was like, yeah, of course I still love birds despite this happening. So we may not like them because of the pooping on our houses. We may have seen movies where birds were not depicted in a very positive light. Or maybe we were attacked by a duck or other bird or something like that. But then there are some of us who just enjoy the simple pleasures of viewing birds. And regarding your view of birds, they're pretty cool. And we're going to talk about why. Quickly, we're going to get in some technical parts of birds. We'll talk a little bit about how birds are important. We'll talk about a little bit of migration, adaptations, identify them, and different classes of birds. So that's kind of what we have on board today. All right. So technical bird, world of birds. What are they? If you were to try to explain some alien, someone just came on land and to Earth and said that animal, and you said it's a bird, how would you describe it? If you were trying to describe what a bird is, what's your description?
Covered in feathers.
Covered in feathers. Bingo. Exactly right. Covered in feathers. So they share different traits, but by definition, a bird animal that's covered in feathers as a diagnostic feature and characteristic. Now, if we were in person, I'd be passing out some feathers right now, but just imagine some virtual feathers. I'm passing them out. There you go. Those are some feathers, okay, right there. But birds are in the class Aves, and the best definition I've seen is a bipedal vertebrate with feathers. So they are vertebrate, meaning they have a backbone, 2 legs, and they have feathers. They share characteristics with other classes such as mammals, which we'll talk about tonight, and reptiles. So when it comes to mammals, they are homeothermic, so they're like mammals in that they can regulate their body temperature. They have a 4-chambered heart, large brain and eyes. They have true flight like the bats, so that's one of the shared characteristics. They also care for the most part, and then of course bipedal locomotion. Now there are some animals that are quadrupedal, right? But they walk on their 2 legs. Reptile-like characteristics. A lot of people associate birds as dinosaurs and associate them with reptiles because their scales are cut, their feet are covered in scales. They lay eggs. Like turtles, they have air sacs. We'll talk about that. and struts to strengthen the ribs. Those are called uncinate processes we'll talk about. And I'm getting a notice saying my internet connection is unstable, and I do apologize. I hope it's not being a deterrent for y'all. All right, so let's talk about some of the features. Now, we said birds are covered in feathers. That's the diagnostic characteristic. But let's talk about some of the things that we associate with birds. And one of the main things is flight, right? So they're built for flight, built to fly. There's two things, main things that allow that. Number one, weight reduction, and number two, duration. We're going to talk about that. But first, let's focus on weight reduction, okay? This is not an ad for a weight loss program, all right? I promise you, all right? So weight reduction, feathers and body systems that are modified and even reduced to allow for that. And those particular systems we're referring to are the skeletal system, the digestive system, the excretory system, and the reproductive. So let's talk about those real quick. So first of all, feathers, as I got those feathers, you would be holding a feather so we can talk about these features, but I'm gonna bank on the fact that y'all dealt with feathers, all right? But they're keratin structures similar to scales and claws, nails and beaks, so they're made out of the same material. There's a wide range. There are some birds that can, you know, as far as number amount, 940 to even 25,000. Now, I'm gonna take their word for it, and I'm not gonna count the 25,000 feathers on a Andean condor or whatever the species. I'm just gonna take their word for it, and I hope that you take my word for it as well. So feathers represent about 9 to 20% of a bird's body weight, so very lightweight. The primary functions of feathers, insulation, allows them to maintain their feathers. You'll see birds, they'll fluff up their time. That's a way to trap all that warm air. Also, opening up those feathers in the summertime allows them to release the heat from their body as well. We're going to talk about that a little bit later. Another primary function is flight. They're essential for flight. You got to have flight. And then for communication and camouflage, so the ability to hide and conceal themselves. Also to communicate, like a red cardinal, a male cardinal is bright red, allows them to, you know, show how beautiful he is to attract a mate. So those are some functions of feathers, and I'm sure you can name some more as well. Keep them dry and so forth, which I'm getting to right here. Secondary functions, swimming, sound production. You know, American woodcock fly off, they flap their wings and they can hit the tips of their wings, causing like a click. St. Anna's hummingbirds, they do that as well. Some feathers are essential for heat. Think about owls. They can, you know, manipulate those feathers in order to get sound in, to find things. Repellency, like your waterfowl, the ability to have that water just run off the duck. Tactile sensation, and that's feathers that allow them to feel. You know, you can touch your eyebrows and your hair, and you can feel with that hair. And they have some tactile, some feathers that allow for that. And even poison. Even some feathers have poison. The I don't know, I'm not going to try saying it. And Ephrita, they actually have poison in their feathers. So those are some functions of feathers. So here's some images of some feathers. You can see the far left picture, you have tail feathers and flight feathers. Now, can someone tell me, what do you see as far as the difference between a tail feather and a flight? What do you notice about that?
They're not
Tail one
symmetrical.
is even and the flight one isn't on both sides. One's symmetrical and the other one's not.
Exactly. So you see a tail feather, great job, Ryan. They're symmetrical with the tail. Flight, it's asymmetrical. And when they put their wings outstretched, it gives them that curve so that the air, you know, bounces off of them. It makes them aerodynamic. So even how the feather is structured allows for flight, and then the tail feathers are more for brakes. So there's no need to have it asymmetrical. So that's pretty cool. Then you have some types of feathers like plumes, breeding egrets and herons will have those phyllo plumes, those long stringy feathers, again for breeding purposes, bristles for tactile, and then downy to keep them warm, and those are typically for the young birds. So those are types of feathers. You move over to the falcon, on your right, you can see the different types of feathers as far as the groups. The feathers that are at the tips, if you imagine their fingers, those are called primary feathers. Think about an eagle and a vulture as they're flying. You see those like fingers, if you will. Those are the primary feathers that allow them to really fly. And then they move up from the tip of the wing to the body. You get secondary and then you get tertiary. So it's typically 10 feathers, 10 primary, 10 secondary, 10 tertiary, and so forth. So those are the flight feathers. And then those are referred to as retrices, and then, remiges, and then the tail feathers are retrices. There's more for direction, braking and so forth. So as you have your imaginary feather, and I was also going to give you a magnifying glass. Oh, I had all the stops for you tonight. Unfortunately, COVID really screwed that up for me. But you would get the feather and you would stretch it out and we would talk about how it gets interconnected. So this picture here tells you the feather structure. So you have that main shaft, just like Ryan was saying as the tail feather, there's a split in the middle, that white line, that's the shaft. So you have the main vein, you can call it main vein, and so forth. And from that shaft, you have all these little barbs. Every one of those little feathers you see that comes out is called a barb. And then on each barb, you have what we call barbules. So you have proximal barbules, which are on the front, and then distal are on the back. So you have barb, and the ones in the front have little openings, and then the barbules on the distal side, they have hooks. And basically what they do is they interlock with each other. And that's how a feather can get fixed. Because it takes a lot of energy to create feathers, as you can imagine. If you have your hair all messed up and so forth like that, it takes effort to comb it, right? Well, not as much effort, instead of shaving it off and growing it again. So what they can do is, here, I'm gonna do that just for a little bit. Okay, there you go. Because I know I'm on TV or on being recorded, so I want to make sure I'm somewhat presentable. So those barbules, they hook together and creates that feather the ability to reconnect and serve those functions that we discussed. So that's the structure. It's kind of grow if you want to compare it to something. Feather tracks, there's different feathers on the bird. Now I got all these pictures from the Sibley guide to Birds of North America. So any bird guide you get at the beginning should have some of these images, but birds are not uniformly covered in feathers, okay? There are bare spots, okay? So long they cover each other, but they do have open skin. So the feather tracks you have they're called terralae. Okay? The apteria is the bare. A pterodon, pterodactyl, think of it that way. Apteria without feathers, it's a bare skin. And then as far as the feathers themselves, there's a follicle at the tip that's, that goes into the skin, into the bird, that move and manipulate, especially to regulate their temperatures. So those are the different tracks. Spend too much time on this because it's kind of small to see in the first few pages, and it shows you the different types of feathers. This is very helpful when you're birding with someone and you're explaining it, and you say, okay, well, I see some yellow on its flanks being the very side part of the bird. You're describing this bird, because I get so many calls, guys. Someone will call me and say, I have a bird in my yard, and it's so fun to listen to these stories and how they describe the birds. And I'm sitting there, what is that? And then they show me a picture, and then oh yeah, that's a so-and-so. Knowing some of these different features and feathers can help whenever you're calling me or someone like, yeah, I noticed there's yellow on the flanks, it has a white throat, crown, or whatever it is. That's very helpful. So just look in your bird guide, and everybody should have a bird guide. All right, feathers.
I'm sorry, this was back to a couple pages back when you were talking about the feathers. I wanted to ask what you were talking how they interconnect.
Yes.
What would make it actually curl up?
Curl.
Like this, where it's curling?
It could be wear and tear on the feather that causes that. If that's what I'm thinking. what you're asking. So, all right. All right, where were we? Oh, I'm going backwards. Okay, so we talked about feathers. Now let's talk about another way that birds reduce their weight, found in their skeletal system. About the bones, how they fuse together, and then how they're lightweight. I'll talk about all these individually. So first of all, hollow bones. There are some bones in birds that are hollowed out. There's spaces. The picture on the left, you can kind of see all those trusses, kind of that go together, interlock to help give it, to make it stable. Because you think, if there's nothing in the middle, how in the world is that bone going to be very strong? Well, all those little trusses and interconnecting gives it the stability. But there's air, there's just hollow in there. And the picture to your right, as you can see the difference. Mammals, have marrow and so forth. Think about a dog, he's got the bone in the back of his mouth, he's chewing it so he can get all that marrow and so forth in the middle. And in a bird, it's just hollowed out, which again reduces its weight. Another part of their skeletal system, not so much weight reduction, but just trying to emphasize the fact that, yes, they're hollow and they may not be as strong, but there's things that they have to help make them strong, like those struts inside of the bone, but also on the outside, on the ribs, they have these, you can see those little projections that stick out, lap. Those are called uncinate processes. It almost connects those ribs and it gives it the stability and sturdiness for flight. So an uncinate process. And then a keel, they have a keel, and that is very important. Now, why do you suppose that keel is an important structure to their skeletal system? What role does that keel play? Anybody want to jump in?
Helps guide them.
Muscle attachment.
Balance.
Muscle attachment, that's great. They're flying, they have strong muscles. So that keel allows for a really a good place to those muscles to be attached. So great job, whoever said that. Birds also reduce their weight because they don't have teeth, okay? I don't know where I got this image, but I thought it was pretty hilarious. A mandrill on a bird body. If you are associated with the University of Louisville or any school that has a cardinal as your mascot, they don't have teeth, okay? Teeth, so you don't have to look really scared. They don't have teeth. So no dentist necessary. You can see the picture to your right there. You can see mouth open, no teeth, and again, reduces his weight. The avian digestive system is helpful for reducing weight. Let's go through that real quick. At the very top, as they are consuming food, this morning, just a little plug with David Hunter, one of our naturals. He joined me for a canoe tour this morning, and we were watching a great egret right off the dock. We're in for a field trip when we first loaded up. There was a great egret there, and he had a fish. It was a pretty good sized fish. This morning it was like this big. It's this big. It's huge now. You know how later in the day, as you tell the story.
It was really big.
Yeah, but it was big, and he was swallowing it, and his esophagus, his throat, it would go into his crop. And hawks and all the birds have that crop where they store food. It gets broken down some more because you think about the advantage of the crop basically allows a bird to eat the food, okay, store it in its body, if you will, so that other animals are not trying to steal it. So it's kind of like it's you licking it. You have that little brother, little sister, you're trying to fight over something and you licked it. Like, oh, I'm not going to eat that now. You licked it. You can have it. Well, in here, they swallow it, goes into the crop. All right, fine. So the crop is basically an extension of the esophagus where it stores food, regulates the flow to the stomach, and digests, okay? Then it goes down into their stomach, and they have a two-part stomach. They have a glandular proventriculus, basically a place where the digestive acids are being produced to allow for it to break down that food. And as it moves down into the second part of the stomach, which is a muscular gizzard, kind of referred to as avian molars, there's keratinized structure to help break down their food. Some birds will swallow stones to help in there to just kind of break it down even further. So that's the digestive system for a bird. And also intestines, they secrete the food to break it down. And then they have a vent, which is multi-purpose. It's used to release solid liquid waste, reproduction, and egg laying. And the reason I bring this all up as far as an advantage or an adaptation for weight reduction is birds, they don't keep a lot of their food in their bodies very much. They don't store it in your gut. You know, I got a big old gut right here. Store all that food, okay? It goes through the digestive system very quickly so that it can reduce its weight, so it's not very heavy. And it's usually in the form of referred to as whitewash, or you may refer to as poop, okay? So they release the whitewash or the poop, whatever you want to call it, very quickly. Think about it. You're sitting there, you're watching a bird. As you get close to the bird, what is one of the first things that bird does? It poops, okay? It releases that weight so it can fly and be lighter. So these are just some fun shirts where it shows the different species of birds and what their poop looks like. And then that there just talks about how there's a bird, so we better leave or it's gonna poop on us or something like that. So anyway, digestive system. Reproductive system actually is helpful to reduce weight as well. Reproduction organs, they shrink to tiny proportions most of the year. So most of the year, they're very, very small. In the case of Japanese quail, their testes they can swell up to 400 times during breeding season. But before that, they're 1/400th or 1/500th of the size during season. So that's a good way to reduce your weight. And Japanese quail, again, can weigh any for 800. They can start at 8 and go up to 3,000 milligrams in a matter of 3 weeks during the reproductive times, breeding season, if you will. And then females have 1 ovary. So that's another way that they reduce their weight as well. Another weight reduction, egg development. All birds lay eggs, okay? So they have a long incubation period, which limits them carrying them in their body. So laying eggs, depositing, laying their eggs, and then incubating on those eggs for a long period of time, again, it gets them out of their body and it reduces their weight. So egg development is very crucial for that. And then most chicks that hatch out of the eggs are altricial, meaning they need the care from their parents. There's some that they hatch and, all right, mom, see you later, I'm done. All right, so that's weight reduction. That's how birds can fly, because they can reduce their weight in so many different areas. Now let's talk about the flight aspect, okay? So they can fly because they reduce their weight, but they can fly because, well, of the things we're gonna talk about. So first of all, they like the heat. The heat's good. Heat is good for them because a couple of things. Now, first of all, birds have high body temperatures. Birds can have a body temperature of 105 to 112 degrees. Think about that fever you've had before, where it's 101 or whatever it is, and you're just like, oh my gosh, I can't take this. Imagine 105 to 112 degrees. Hey, caramba, that's hot. And that's also one of the reasons why birds can stay in cold regions. We think about birds gets cold, but there are birds like the gyrfalcons up in the northern United States into Canada. They can withstand cold temperatures because of that. I used to work in Salt Lake City, and we had some birds we used for education programs. And during the winter months, we had Swainson's hawks. I'll go in there and get the Swainson's hawk. We had one that was just so great temperament. And I would dress it, put the jesses on and get it ready. And I would just sneak my hand up there in the feathers. Oh my, it was so warm. It felt so good. I'm sitting there, okay, just give me a second, warm my hands up, and then I'll finish dressing you. But body temperature, and because of that, it increases their reflex speed and even their power and endurance. That with a higher body temperature in birds, that increases the nerve impulses, also the muscle speed and the strength increases with that higher body temperature. So think about you're probably more active when it's warm. I know kids too. Cold, he's like, I want to be inside, sit by a fire and read a book or whatever the case is. And that's just true for birds as well. Whenever they experience heat waves, they do experience it. They don't have sweat glands. They're not like us, they can sweat. So they have to release the heat by opening up those feathers and releasing the heat. But they also will do a couple of things. You see a picture here of a brown pelican. It's panting. It's got its mouth open. It's panting. Gular, that big pouch is called a gular sac, gular pouch, and it flutters and it releases. One of the other cool things that birds do, particularly vultures, and I love telling people about this because it's gross, but science is gross. They practice a process called urohydrosis, which is basically they defecate on their legs as a form of evaporative cooling. That's why you see vultures have a lot light colored legs, because they do a lot of defecating on their legs. Kids love that.
Michael, I thought that was to help them also to keep the bugs off of their legs. Is that not true?
Oh yeah, and everything I'm telling you, there are multiple benefits from some of the things they do. You know, so yes, they definitely do that to get rid of insects, mites. Birds, you'll see them. You see the vultures when they have their wings open, they're sitting in the sun. They're letting the sun just get rid of all the mites. So that's another way that they do it. So definitely. All right, the opposite, cold. Well, how do they handle? Well, typically the birds in the northern areas are a little larger, allows them to generate more warmth. They have an elevated amount of blood flow to their legs and their head, so they can stay warm and well circulated. As I said, they fluff their feathers. You'll also see them huddling. And back in 2009, way back in 2009, we had some snow. You remember that white stuff that kind of just falls down from the sky? Well, we had some back in that year. And I remember hiking around the nature center, and we're underneath one of the eastern red cedars were all these mourning doves. And they were all huddled, I mean, one by one, in order to be warm. This was probably in February, if I remember right. No, this is December. So they're all huddled together. So that's another way to set off the cold, being cold, shivering, and we do that as well. Some birds go through a state of torpor. Hummingbirds are a great example of that. At night, they'll actually reduce their body temperature down to even into the 50s, so that, well, if their body temperature is 50 degrees, and it's 50 degrees outside, it's not so bad after all, right? Fluctuate that temperature, and I don't know all the species that do it, but hummingbirds are definitely famous for that. And then muscle, we talked about that keel, having a muscle attachment. You see those big, strong muscles, the pectoralis that's attached to the keel, as well as the supracorticoideus muscle. Again, that gives them that flight, the ability to fly. Moving on to the respiratory system, this is very helpful for flight because they're very efficient when it comes to respiration. They can take anywhere at least up to 95% of oxygen from the air by the process of utilizing air sacs and their lung capacity. So here's a picture of a duck. You can see the different types of air sacs they have. Interclavicular sacs, cervical sac, abdominal, all over their body, all series of air sacs. And how do they make the bird efficient? Well, this is how they do it. So here's a diagram of inhalations and exhalations. So breathing in, breathing out. So the very top one, I'll start with number 1. That's the top, go down to 4. And number 1, you can see at the very bottom that's the first inhalation. They're taking in the air, and it goes all the way to the posterior air sacs. And amongst that air, in those posterior air sacs, they're just getting all that oxygen from that first inhalation. And then that first exhalation, all that air that's been taken in the posterior air sacs goes into the lungs. So that's image number 2, where all the lines are. That's the lungs. So the lungs getting all the oxygen in there. And then they have a second inhalation. So that same air is still being processed and worked, and it goes into the air. I can't remember what the anterior air sacs, the front one. Again, taking in all the oxygen there, and then the second exhalation, they release it out. So we breathe in 1 exhalation, 1 or inhalation, 1 exhalation. So we only have that 2-way. They have it 4 times, and it allows them to get all that all that oxygen from that. And And that's very efficient when they're flying. To pump more blood around through their body allows them to flap their wings faster, gets their heartbeat going, gets blood out, so they're more active. They can flutter their wings. And also they have a heightened blood flow in their legs and their heads. And we talked a little bit about that, where I mentioned it, where the airs tend to be cold. Think about your head and your legs. Typically you get colder there on your and so forth. And then a general rule is the heart rate increases as the bird decreases. So the smaller the bird, the faster the heartbeat. Okay, so hummingbirds can beat up to 300 beats per minute. Again, smaller bird, faster the heartbeat, and then generally have the largest hearts relative to size. So they're a good example of how the system helps them in their flight. All right, so that's the technical part of birds and how they use those different systems to help them to fly and so forth. Now let's talk a little bit about the conservation aspect of it. I'm watching my clock. We're approaching 7 o'clock, so I apologize. I'm going to get through these real quick. Effort and importance. This is the take-home message. This is why birds are important. Okay, but before that, we need to understand the different eras that birds have gone through as far as conservation. Human expansion, the era of exploitation, our chemical era, and then also globalization in modern life. So let's talk about those 4 different eras real quick. So first of all, in the BCs up to 1000 AD, you had the Polynesian expansion, you had people expanding, and as a result, a lot of birds were lost because of that. Over 3,000 species went extinct during this time due to rats, pigs, goats as well. So when we explored, birds were not on the receiving end of that or benefit of that. And then fast forward to now, but early, 1800s or so, exploitation. So in the East, as we, manifested our way from East, deforestation was a thing. Loss of the forest specialists, the birds that focused on the forest, like woodpeckers, they were under exploitation because of that. Even market hunting, shorebirds and hawks. Here's from a newspaper up in Ohio, the legislator. Get this, you love this. I don't love this, but just listen. Passenger pigeon requiring no protection because no ordinary destruction can lessen them or be missed from the myriads that are yearly produced. Passenger pigeons everywhere. They're in the eastern, northeast part of the United States. They're everywhere. And this here in the Ohio legislature, there's nothing. They're saying there's nothing we can do to cause those populations to decline for it to become endangered or extinct. Well, we know that's not the truth because passenger pigeons are one of the losses due to the era of exploitation. Among others, I'm not going to go through all that list, but you can see a list there. At the very bottom, I have ivory-billed woodpecker, question mark. When I lived in Atlanta, there was a story out that ivory-billed woodpeckers who had not been seen since the early, 60s, and the last one was, I think, Cuba or some place like that, were being seen in Arkansas, in the bottomland swamps of Arkansas. I had friends from Atlanta. They would drive over there and they would do searches. They never found one, but there's hope. Maybe there's an ivory-billed out there. We did get a pileated on our canoe tour, so a little plug for our canoe tour. All right, now move into the chemical. We're talking about DDT. DDT was used to get rid of mosquitoes and bugs, but it put birds on the brink of extinction, such as falcons, eagles, and so forth. And DDT was not killing them directly. It was an indirect mortality because it would bioaccumulate in the body of a bird. Okay, it would just build up and build up and build up. And what it would do, it affected the way that a female, when she was laying egg or developing eggs, it created a very thin shell, and in some cases, shell at all. So that when a female would incubate the egg, it would just crack, and the mortality rate was increased because of that. So there wasn't not an influx of young future generations of falcons, eagles, and pelicans. So we got rid of that because of a lot of things. Silent Spring. Anyone ever read Silent Spring by
yeah.
chance? Okay, so that led to some, so Rachel Carson's book, the banning of DDT here in the US, and then also the creation of the Endangered Species Act. So these were things that were combating that chemical era to allow for bird populations to recoup because they were definitely in decline. And lastly, globalization. They drive land use. You think about timber, mining, agriculture, and so forth. And we need those things. Agriculture and crops and so forth. But everything, like everything, we just got to use best practices possible to create a balance between our wildlife and our everyday needs. So that is something that birds have to deal with as far as their decline. And in modern, more specific to now, just habitat loss. That's the #1 reason why an animal becomes endangered. Fire suppression. So not introducing fire and doing prescribed burns and control burns. It causes forest areas to just thicken, and then the bird will leave. Invasive species, they bring their diseases and they're more susceptible to maybe our diseases, and they outcompete our avian species. Collisions, man, that is a big one. When I worked in Georgia, my mentor, he was part of where we would go during the migration time. We would go down to downtown Atlanta with all these tall buildings, and we would collect birds that have, as they're migrating, they collide into these big, skyscrapers. And I'm not kidding you. Every morning we would come back with trash bags full of birds that have collided in tall structures. Not to mention turbines, and more recently, light pollution. It causes birds to get off track. So those are some modern things that we need to consider and help make for a more concerted effort. Now, one thing I encourage y'all to look at, Google North American Bird Conservation Initiative, not right now, but also Google 2019 State of the Birds. Every year, this organization puts out these State of the Birds. How are they doing? And a lot of this information is coming from citizen scientists, biologists that are doing bird surveys and so forth. Really interesting document. I encourage you to read it. It's very simple. You can go through it very easily. Through it. If I can do it, you can do it. So the State of the Birds. What do you think the state of the birds in 2019? Overall, what do you think? Good, bad, no big deal. Maybe you agree like the Ohio legislator. Oh, there's nothing we can do.
Getting a lot better.
Yeah, they're less. So when you click on this document, they'll have a couple pages. I'm going to show you real quick. This is one of the first things you see. #1, overall.
Some of them are getting better, some of them not so much.
Well, and that's what this is going to show you. Yes, there are some obviously better than others and worse off than others. So real quickly, that document shows you there's a #1, there's a steep decline in bird populations. For forest birds, since 1970, we're seeing a decrease of 22% of the population. Shorebirds, about 37% decrease, and grassland birds over 53% since 1970. Collected data for this project. So overall, there is a decline. Now there is good news. We always want to start with the bad, right? I want to get you zoned in. So there is the decline, but there is some conservation success. You can't read some of those things, but go on that website and check it out. But there's funding in the western states that to help millions of acres for sage grouse, but there's also some opposition, and I don't want to get in that right now because there is. But there are some success stories. And I'm not going to go through all these, but look at that website and I'll show you again, and maybe Mary Beth can put it at or somebody, that website or the organization. And I'll go back to it in a second. So help us. Birds need our help because there's some places where birds are being listed as a species of concern. One of my favorite, common nighthawks. Guys, during the summertime, if you're at a ballpark or a parking lot, you're grocery shopping. I even have them around my front yard. The nighthawks come and they're eating insects. They got their mouth open wide and they're just flying around eating insects. So they help with insect control and so forth. So again, you can look at that. I'm not going to go through all that for you, but we can help them, by making joining groups and contributing to organizations that help them. So why are birds helpful? We talked about the conservation. We notice and there's a decline. Well, why should we help them? Well, there's so many reasons why. Here's a laundry list of some that we're going to talk about real quick. I'm not going to read this whole list because we're going to go through them. But environmental indicators, they help with disease control, dispersing seeds, pollinators, all sorts of things. So let's quickly go through some of these. So they're environmental indicators. And what that means is, what I'm trying to say is, they tell us how healthy an environment is, an ecosystem, a habitat is. For example, if you are out birding, you're out in a certain area and you see hawks flying, you see meadowlarks and all these different diversity of birds, that should tell you this area here is healthy because there's a wide diversity of wildlife, birds in particular, talking about birds that eat other birds, eat a mammal, and those that eat the plants, the seeds, and so they tell us how well. If you go in an area where you don't see hawks and falcons and other birds over a long period of time, I'm not talking about like a day or two, you went birding and you got shut out, you feel bad, it's like, oh, because it's a bad habitat. That's not the case. Over a series of time, that can indicate how that habitat may not be healthy. And that's something that we should, alert, our biologists and so forth. And we get calls a lot of times. Well, I've noticed that a particular bird I haven't seen in a while, and those are important. There's a bird call survey. It's called the Cascade Bird, where birds are starting to arrive later. And I've noticed birds here that spend summers here. They take a long time, or they stay here longer because, well into October, it's still warm and they're good because the insects are here. Why fly away when I have food right here? So it's an indicator of, where you are on climate change, but the temperatures are different. It's just a different time. Maybe it's a cycle and so forth, whatever it is, but the facts are showing the last few years, it's warmer throughout the wintertime or fall. And that's causing birds to leave later. And that is an impact for they are going, because those are where they're going to be exploited and to take residence. Loons, less amount of loons can be an indication of mercury and the coal impact. So there's just so many things. I'm going to kind of move on because I have several others. But they're environmental indicators, how healthy a habitat is. Insect control. Like I said, I used to live in Salt Lake. The state bird for the state of Utah is the ring-billed gull. And it's because as the Mormon settlers came in, they would try to get all these crops going, and all the grasshoppers and locusts, whatever, would devastate the fields. But then here comes the California gull, the ring-billed gull, and so forth, and got rid of, all those insects. So they're good for insect control. I put here Missouri white oaks. There are birds that help eat boring insects that affect the trees that in turn are being used for furniture and other everyday objects. So birds help with that. And then Napa Valley. I know Robin, I think you a glass of wine one of our nights that we were together. Well, because you're allowed to have that because they help control some of those pests that affect the wine growth of the wine industry as well. So that's a
Very cool. Yes, I'm even drinking wine right now. I'd show you if my camera was working. So I have wine to get together.
I figured you would. So again, a toast to the bird.
A toast to the birds.
All right. Disease control. Vultures are good because they eat dead stuff that rot and can cause disease. In India, there was an actual anti-inflammatory that was given to livestock where the vultures, whenever they died, the vultures would eat the livestock and it caused them to go in renal failure and die. And so the population of vultures were going significantly down. So they realized that and said, so they got rid of that for the most part, use an alternative, and it's helped so those populations are rebounding. And the effect of that, because those populations were going down, the number of feral hogs increased, rabies, rats, and all these diseases because there was no vultures to take care of that. So it also contaminated drinking water. And as a result, whenever that was happening, they would face, it was like equivalent to like $25 billion effect because of all the contamination of water and all the other effects, because there were no vultures getting rid of those carcasses. So vultures are very important. They disperse seeds. There's a tree called the white-barked pine that has blister rust. But this bird here, anybody know what it is?
No.
Clark's nutcracker.
Way to go, way to go. It is a Clark's nutcracker. And I do appreciate the honesty of the person who said no. Good job. So anyway, this Clark's nutcracker, without this bird here, they can actually open up the pine cones and disperse those seeds. So they're very crucial and helpful to spread seeds so we have more white-barked pine and prevent that blister rust from overtaking the tree population. I'm going to skip the Costa Rican bellbirds because I'm running out of time. But also hobbyists, tourism. The Maggie Marsh up in Ohio, they generate over $26 million in revenue. They created all these jobs because of tours and so forth. And it creates a story for the birds and gives them a platform to talk a little bit about the birds and the importance of birds. U.S. Fish and Wildlife Service, they gain $24 billion in equipment. They sell for that. They make that money in selling equipment. Tour guides. If you've ever been down to the tropics, Costa Rica or so forth, if you hire a guide, that guide tells you everything you need to know about birds and where you find the good ones. Well, you got to pay them for it. Again, it's revenue, and you're helping someone down, with a job essentially. So, and then the non-monetary value, it's the improves your cognitive and your mental health. Just sitting out, listening to birds and seeing birds, that does a lot for your soul. At least it does for mine. Okay, so last thing, what's being done? Well, each state has a wildlife action plan. It gives landowners incentives to help provide habitat for wildlife, birds, and so forth. And maybe Nick knows more about that. He's with Texas Parks and Wildlife. He may be able to shed more on that. Buying and managing land. People buying land like Audubon. What's the other group I'm trying to think of? There's another group, big group. Purchases land to use for preservation and conserve wildlife. A lot of research and education. There's me. You recognize me. But talking a little bit about the importance of these animals and birds and raptors in particular. So a lot's being done for them. I'm going to go ahead and have a lot of more slides talk about citizen science as well as bird identification, which I'm happy to do, Melinda, another like a advanced training, if you will, or a little program about bird identification, bird songs as a way to gain some advanced training hours. So I'm going to save the rest of these slides for that because I'm running out of time and I don't want to get...
We do have some questions.
I'm sorry?
We have some questions.
I will definitely, yes, I'm going to get some questions. Yes, I was just saying.
Okay.
I'm going to skip this for right now.
Okay.
Fast forward and I'll get some questions. All right. Need some music or something. I'll go over here in a second, but let me go ahead and take some questions.
Okay, this is from Joan. Can you explain regurgitation for feeding chicks?
Regurgitation for feeding chicks. So the mother bird, obviously she's feeding her young, and the bird can't handle everything that the adult bird can. So regurgitating food is one way to make food more available to swallow and so forth to eat when they're young, as well as cutting pieces of meat into smaller pieces so they can handle. So it's the ability to help them digest and manage food consumption.
Okay, this is what factors led to the explosion of the grackle populations?
That's a great question. It's the increase of Taco Bells, McDonald's. That's a great question. And some birds are a little more prolific when it comes to having young, and grackles are that. Grackles, they adapt to urban areas quite a bit, and we've become more urban. So, they can hang out in parking lots and eat, food on the ground and so forth. So I think it's both of the urban that has allowed for them a place to find food. Nature Center, for example, I hardly ever see grackles there.
Ah.
And it's because it's a natural area. They have natural predators, if you will. In the urban areas, not as much. So I think that's part of it. The urban growth and the lack of true high density.
That's a really good explanation. Thank you. And then can we add domesticated cats to the list of the bird demise?
Yes, definitely. Feral cats do have play a role in the number of birds, the decline in birds. That's definitely true. I leave that for Rachel Richter because she talks more about the urban aspect of it. And I know she talks more about greater detail, but yes, feral cats do play a role in that. I'm going to tell you, my mom, she has cats, she feeds, and it's enjoyable to her. I don't, her face or anything, but yes, it is true. They do.
Okay. And then there are several of us, including me, that would like to have an advanced training on birds.
Yeah, we could definitely set something up for sure. Yeah, I could definitely do something for that. And I can make that happen. I'd be happy.
All right. Thank you very much. That was really informative and interesting. And nice slides.
Well, good. And there's a lot of information there, and I didn't talk about a lot of stuff. As you saw, I went through it, but I want to be respectful to your time and to Nick's time, and we can do advanced training. But the last thing I want to end with is a reminder on the forest field trip. Spoke to Laura today. She says she gave you this slide, so if you want to take a screenshot of it or write this information down, there's Laura. That's her cell phone, much like I gave you my cell phone. Please let her know if you're not attending or if you're running late Saturday morning. Communication. She's like myself, the lead for the trip, so she needs to know. And it's okay to let Melinda know as well, so forth, but please let her know if you're not coming. I do know of one person who's communicated with me. I've told Laura that, I've told Melinda, so we're good there. But if you're not gonna be there or you're running late, please let her know. The trip is this Saturday from 9 a.m. to 3 p.m. You're gonna meet at the same spot that you met with me at the service center. It's gonna be a little bit different. We are gonna divide up in 3 groups, so you can have 3 rotations. One group will be with Tom Haas. He's with the 4th Audubon Society. He serves on the board with me. Great guy, loves birds, and you're gonna love him. He asks that if you have binoculars, bring them. If you have a field guide, bring that. Bird apps like that have bird calls or identification on it. And I usually don't think about this, but he mentioned earth tone clothing recommended. Like you don't want to stick out like a sore thumb. So, but you also don't want to be in full camouflage regalia or whatever, okay? But some earth tones that you blend in, and that's probably better for birds. That's a good point. Then
Any more questions? I'm sorry. Can you recommend a good bird ID app? And what's your favorite field guide?
Okay, favorite bird app. I have the one I have is the David Sibley. It's a Sibley guide to birds of North America. I have that app where it's basically the book, his bird guide on an app. It gives you pictures, maps, bird calls, all that information. And then the bird guide is the Sibley Guide to Birds of Eastern North America is what I there are two types. You have those that have images, like actual photos, like a Ken Kaufman guide, which I recommend. And then you have artwork like David Sibley. The artwork I like because he overdoes it. He gives you normally see, this is what that bird looks like, with great lighting. However, we know we don't always have great lighting. So the Ken Kaufman guide is really good because there are photos in the wild. So I recommend the Sibley Guide to Birds of Eastern North America, the Ken Kaufman Guide, and the National Geographic Guide to Birds of North America. Those are the three that I go to all the time. And then back to the field trip, the other two groups, a group would be with Laura and then I think another staff member. I think it's gonna be Dustin. Y'all are with him with Michael Smith on the herping part. You're gonna have a group and then you'll rotate amongst the three groups. And that is to get that number down so that we're not, have 12, 13 people. We'll have a small group of 8, 10, and small groups usually work really well. So the key is call Laura, email Laura, meet there at 9 o'clock at the service center, wear comfortable shoes. You're gonna be the whole time, so sturdy shoes, bring a backpack with some snacks, insect repellent, the whole 9 yards, and you know that. So I'm gonna stop talking. Any last remaining before I give y'all a quick 10-minute break and we'll get Nick on here.
Michael, I have a question, please.
Yes, Don.
Just to clarify, what are the 3 components of the forest field trip? You said
Yeah.
birding, and what are the other 2?
Birding, and I'm going to be honest with you, I don't know the other 2 components because she didn't give me very many details. She's restructuring a little bit so we have patients, so there's smaller groups. I do know birding is one of the components with Tom, and the other 2, I don't know. I'll be honest.
Get it from Laura.
I'm sorry?
I'll get it from Laura.
Yeah, send or call her and she'd be happy to tell you those.
Okay. The other thing I wanted to mention, those 3 folks who are using Michael Perez's sign in, would you please just send me a chat with your name so I can make sure I've got the right people in attendance. I really appreciate it. Thanks.
Yes. All right, guys. Well, thank you. We're going to take a quick 10-minute break, and then I'll come back on and introduce our next speaker.
Thank you, Michael.
Uh-huh.
You can't stay up late. You must go to bed. You have school tomorrow.
Hey, Michael, I've had a screech owl here, actually 2 screech owls the last 2 nights. I'm hoping they come back on. I'll turn on the mic if you want me to, if they do show back.
Yeah, that'd be really cool. We used to have owls in our backyard too. The sound of the screech owl.
They're kind of haunting. I love them. And when people ask me what they sound like, I always say it's like Mogwai.
Yeah, those are pretty cool.
Sharp beaks, though.
Oh yeah.
So Michael,
Yes.
hi, I'm Glory. I work for the city of Fort Worth too.
Oh, excellent.
I've got a little funny bird tidbit for you.
Okay.
Have you ever been to Village Creek Water Reclamation Facility?
Oh yeah, definitely.
Okay. Well, have you ever noticed how the gulls, have you done like a tour of it?
Oh yeah, I mean, I go, well, not a tour, but I go out there a lot, but I haven't done a tour.
So I do tours at the facility, and in the primary area where the raw wastewater comes in, we have clarifiers, and it's
You there?
basically raw waste. I'm here. Can you hear me?
Yes, I hear you now.
Okay.
Uh-huh.
So in our area, we have primary clarifiers, which is the raw wastewater, and the seagulls love the primary clarifier out of the primary clarifiers because corn isn't digested by.
Kind of breaking up a little bit there.
Yeah, I don't know why. I don't know why.
You keep going on and off mute. You mute and then you don't mute, and then you mute and then you don't mute.
I know, but I'm not touching it. I don't know why it's doing that.
Try holding down the space bar, see if that helps.
Okay. Well, maybe my dog is messing with it too. So can you hear me now?
Yes.
Okay. So hopefully this will work. But in the primary clarifiers where the raw wastewater comes in, the seagulls, if you notice, seagulls are always in the area, and what they're doing is they're picking corn out of the wastewater.
Oh, really?
Yeah, because humans don't digest corn, so they like to just sit there and pick through the primary clarifiers, which is basically the raw wastewater.
Right.
Do you work there, Glory?
I do. I work at Village Creek. I do tours there.
Oh, that's so exciting. I think I've probably met you. I work at Tarrant Regional Water District.
Oh yeah, you probably have. Before COVID, of course, I was doing the tours
Yes,
there.
I've taken the tour twice. I love your plant. I talk about it all the time.
Oh, well, thank you.
It's amazing.
Was I your tour guide?
Probably. I came out there. I went through engineering late in life, and I went out there with a class from UTA.
Okay, how long ago?
Oh, maybe 8 years ago.
No, that wouldn't have been me. But I do them now. Well, again, before COVID.
And then there was a group from TRWD that came out. I can't remember why.
Yeah, they came. It was a water professional. Well, I don't know. I definitely gave.
I can't remember.
I gave a tour to some water professionals, and there were some TWRD people there. So
yeah.
I would attend the classes at UTA that TCQ and all those would have once a year.
I'm sorry?
The classes, the 3-day classes that were always held at UTA once a year. I think it was TRW that was putting them on. Did either of you ladies ever go to those?
The one that Dr. Sayo and Dr. Zhang put on?
Actually, this is usually the Water Association.
Oh, no, I don't think I've been to those.
You're not talking about the Environmental Training Institute, no?
No, I'm trying to remember what it's called. I know usually held every year. It's lasted 4 days. All the different classes. You could even get your licensing, Class A through D, on the TCQ.
Oh, for water
license.
treatment plant operators?
Those two. It's everybody. It was at UTA. If we were short on hours, we would take a couple classes through that.
Was it through the engineering, civil engineering department?
I think so, yeah. It was always in May. I was just wondering if you ladies had been there, because I might have bumped into you there.
No, I like I said, I've done tours for UTA, so I do almost all the tours for UTA. So if you guys came in the plan, I was probably the tour guide if it's been within the last 5 years.
I bet you hear some interesting questions.
Oh God, yes. For sure.
Okay, I have a funny story. I just recently, I'm a runner and a walker, and I just recently was over at Bachman Lake, but walking and running. But I remember touring the Bachman Lake water treatment plant with my UTA class. And as we walked up, one of the distilling basins had a rat in it. And it was just twirling around in the water, and the young women in the class were all, you know, screeching and ooh and ah and awful. And I just thought it was really funny. And that plant serves Highland Park and University Park, which made it even funnier.
Well, I mean, we find everything, we find all kinds of things in the headworks. And one time I was giving a tour and we were looking down at the raw water coming in, and I think it was a dead possum. I don't know how they get in the sewer lines, but they do. And this kid kept going, "Is that a potato? Is that a potato?" I'm like, "No, a potato would disintegrate it in the water." I'm like, I think it's a dead possum. And it was a guy. He looked so horrified. He's like, "Oh my God." I'm like, well, I don't know. Somehow they die and get in the sewer system, or get in the sewer system and die. I don't know. But we find everything there at the headworks. I used to do Waterama when we did Waterama for the city of Fort Worth. And that's just, we teach like 4th graders all about water. And we made this jar of things that we pull out of the headworks, which is where we take out all the trash. And there was money, toys, toothbrushes, cell phones, anything you could think of, we find over there, you know. So like the guy at the headworks was gathering, he only spent a few minutes and he found like $23 in like 15 minutes. You could get rich if you sat there and wanted to comb through all that money, but then you'd have to wash it too.
All right, guys. Conversation. All good things come to an end. So we're going to go ahead and regather and get started on our second portion. We have, again, 2 speakers. You're getting a better speaker now. You're done with me. Now we're moving on to a better speaker, all right? So we're going to get started and talk about mammals. And our instructor for our mammal section is Mr. Nicholas Griffin. He's with the Texas Parks and Wildlife Division. He can tell you maybe real quickly about what he does there with Texas Parks and Wildlife. Nick used to be an employee at the Nature Center as well. And again, Nick, we miss you. We loved having you. You would love Nick. He's awesome, very knowledgeable, inquisitive, curious, and a life learner. So you're going to enjoy him and his presentation. So he's going to be talking to about mammals. So if everyone can give him your attention, and I will go ahead and turn it over to you, Nick. Talk to us a little bit about mammals.
All right. I appreciate it, Mike. Yeah, I missed the Nature Center too. Really enjoyed my time there. But yeah, so like Mike said, I'm Nicholas Griffin. I work for Parks and Wildlife. Been with the agency a little over 2 years now, and I actually work in the inland fisheries side. So we cover Tarrant, Dallas, Rockwall, and Denton counties, and we stock fish and manage our local lakes. And might be asking yourself, what's a fish guy talking about mammals for? And first of all, I am mammals, so there's that. But no, I actually have a background in wildlife. I was in the Marine Corps for 5 years, and when I got out, I was figuring out what I was going to do, and I saw this wildlife program that Tarleton offered, and I was like, yes, that's lifelong outdoorsman, hunter, fisherman, and I was like, that's what I want to do. I loved it. Went to Tarleton, got wildlife management degree, did my internship at the Fort Worth Nature Center, and that's kind of where I'm a big skull guy. We're going to talk a little bit later about skulls, and I love skulls. And when I took mammalogy, I just absolutely really enjoyed the class. It's super hard, but obviously you learn the most from those courses. So really enjoyed it. And I also wanted to say before if you had to leave, I got my bird guide right here. So said I always have one. Got that there. But let's get into it. And I'll probably be asking some questions. This is my first Zoom instruction course here, so you have to bear with me. But I'll ask some questions. You can type it in or speak up. Can y'all hear me all right? I can't hear anybody else, so I'm assuming y'all can hear me. Okay, I got some head shaking going on.
Yes, we can hear you.
Okay, yeah, I got you now. All right, let me see if I start this screen sharing. How's that look?
Quick question. You say you like skulls. If you ever want a possum one, though, I'm sure you've got quite a few. I have a whole skeleton.
Oh, yeah. It's pretty funny. As I worked at the Nature Center, people were always bringing me dead carcasses and things like that. And they always, Mike still asks me to this day, hey, I got this, you want this? And yeah, you got this. Remember, recognize this guy, Mike? This is the possum from the Nature Center. But yeah, so I'm always interested in that kind of stuff. But all right, let's get into it. So I chose this picture for the beginning because isn't this the quintessential mammal that you think of, the old armadillo? I couldn't pass that up. So what we're going to talk about through this presentation, what is a mammal, mammal taxonomy, mammal origins, dentition, adaptations, locomotion, reproduction, and my favorite will be skull ID at the end, and then we'll go over common skulls you'll find around here, how to ID them, and things to look for. So, how can I see the chat here? Y'all speak up, and what comes to mind when I say what is a mammal?
Hair.
Hair. Hair's good.
Memory glands.
Mammary glands.
Warm-blooded.
Yep.
Live young.
Live young, but not only mammals. Some snakes give birth to live young too. So it's not a defining characteristic, but it is a good one. All right, well, when I was taking mammalogy at Tarleton, the professor gave this perfect definition, I thought, is mammals are hirsute, lactogenic, endothermic, homeotherm. So quite a mouthful, but next time if you ever ask or talk about mammals, just say, yeah, they're hirsute, lactogenic, endothermic, homeotherms, and you'll be good to go. So we'll break that down. Hirsute, I heard somebody say hair. Lactogenic, milk, yep, producing milk. Endotherm, warm-blooded, homeothermic, they maintain that body temperature at a constant level. So endothermy, go ahead.
Forgive me. I was going to say not always hair, because you have like the naked cats and the naked rats and others.
Right. Yeah. Even there may be mostly, yeah, there would still be a little bit of hair like on your armadillos and things like that. But endothermy, like maintenance of your relative constant body temperature by means of heat produced from inside the body. So you're producing that through your metabolic rate. It's coming from inside, not an outside source. And homeothermy, like Michael said in his presentation, it's your constant temperature at that level. And we'll break that down, mammal taxon. So the kingdom Animalia obviously covers all animals. Break that further down. Everyone remembers King Philip came over for a good soup, right, from biology. So the next step down would be phylum Chordata, subphylum vertebrates, class mammals, and then we break that a little bit further down into subclass Protheria, subclass Theria, and then infraclass Metatheria, and infraclass Eutheria. So chordates, this is obviously a huge encompassing, it's big group, which possess a notive cord, a hollow dorsal nerve cord, pharyngeal slits, endostyle, postanal tail, at least some of your period. So we had this at some period during your life cycle. although be it short, you do have it. So like even coral is a chordate. So all encompassing basically. And then subphylum vertebrates, obviously with backbones, and then of course mammals, hirsute, lactogenic, endothermic, homeotherms. So one step further down, we got your subclass Protheria, or pro first, egg-laying mammals. And then over subclass Theria, infraclass middle beasts, which are your marsupials, and then Eutheria are all your other mammals like we are. So they came about approximately 250 million years ago, and they came around, and they were, you know, the dinosaurs were abundant and roaming around, and these were tiny, tiny little guys. Like you can see this guy, he's the size of a paperclip, and kind of ran around at night, which kind of, most mammals have, are colorblind or don't do well with colors, and it's kind of, they evolved at night and run around at night and things like that. A long, long time ago, obviously. Then we see some evolutionary changes with jaw manipulation, heterodont dentition, limbs rotated out from 90 degrees. So you think like a alligator or a Komodo dragon, you know, they're kind of walking out there like this, but they rotated in directly underneath. So you think like a cheetah that's running really fast, along with many other things. But this jaw manipulation and heterodont dentition, so think reptiles, they have teeth, but they're all the same, where we have incisors, canines, molars, and premolars, and that's a huge step. Opens up a world of things to eat and to chew and things like that. So big deal. More on the heterodont dentitions. So like I was saying, much of the mammal success is related to their teeth. So you want to eat meat, become a carnivore, get sharp teeth. You want to be a herbivore, you know, go that route. You don't always have that option if you just have the same kind of teeth. So mammals are the only vertebrates that masticate. They chew their food. They can break it down. Think about cows out in the pasture breaking down that grass. Vegetation is really hard to break down, that cell wall. So you can see them really constantly chewing, and you know, really chewing the cud, right? But it allows them to do that, and they're very good at it. So dentition is such a big deal. They come up with the tooth formulas, and it's broken down like upper jaw on top, lower jaw on bottom, and it goes always incisors, canines, premolars, and molars. And just because you have the same amount of premolars on top doesn't mean you have the same amount on bottom. And the difference between a premolar and a molar is a premolar gets replaced, so you'll lose that. You'll lose it, and it'll be replaced. And molars, they just come in, and that's what you get. Here's an example of a cat. You got 3 incisors. It's broken down too from your left to your right. So you have 6 on top, but you're only going to do one side. 3 incisors, 1 canine, 3 premolars, and 1 molar on top, and then 3, 1, 2, and 1 on the bottom. So more about teeth. I probably didn't think we were going to talk about this much about teeth, but it's very important. It's really cool. Here's an example. This is a deer. It's a selenodont dentition. I have a jaw here. It's kind of hard to see, but you can see better from the picture. Those ridges run in line with the jaw. You can kind of see they're parallel with the jaw. And here we have a lopodont dentition, and these ridges run transverse. Another one we have is cecodont, sharp edge, your carnivores, and then bunodont. This is what we have, you know, omnivore teeth. Here's a picture of a pig's lower jaw, but just like ours, omnivores ready to break down most anything. Adaptations, obviously you can see here we have, you know, quite a bit of difference. Some really cool things to talk about here. So these are quote unquote ecological rules. Allen's rules state that extremities are reduced in animals inhabiting colder regions. So like you just saw with the jackrabbit here, it's got large ears, long legs, where the snow hare is real short, stubby, and so that helps them out. And then Bergman's rule states that animals increase with body size with increased altitude or latitude. So like, if anybody's from up north, but big thing is like white-tailed deer around here, yeah, they're fairly big, but when you start going up through Kansas, they're known for real big white-tailed deer. And in Canada, and so this is kind of a rule that if you have one critter that's further south, it's almost certain that that critter is going to be a larger size as you move up in latitude. And so as an animal's size increases, their volume and mass change more rapidly than their area does. So as you get bigger, your volumes increase a lot more than your surface area. And that plays a big deal into, like losing heat and things like that. I'm sure, surface area is huge in everything that you do. Think about your small intestines, your microvilli, breaking down food, your taste buds, everything's about surface area. It's a really big deal. And then when you get hot, you want to just kind of lay down out in the grass and spread out. You're basically increasing your surface area, right? And you're going to cool down. And you get cold, what do? You bundle up. You're decreasing your surface area to keep that heat in. So with the temperature regulation, most mammals don't migrate. So like Mike was saying, birds will say, man, it's getting cold here. Not that they couldn't handle it, but then the food kind of dwindles, so they just head down south. Well, a lot of mammals don't have that option. And then linear relationship between body size and metabolism. The smaller you are, the higher metabolism you're going to have. Think about, the mice elephant deal. Insulation, hair, your appendages, big ears, little ears, long legs, short legs, and then your coloration, dark versus white, and then dormancy, say, hey, it's too cold, I'm just going to take a nap, hibernate, and I'll wake up when it gets a little bit better outside. So things to deal with the heat, adaptations, we have sweating and panting, really cooling down, start sweating, evaporative cooling. The large ears, like we saw in the jackrabbit, it's going to dissipate that heat. Countercurrent heat exchange is really cool. We'll get to that in a little bit in a minute, but you think about the veins on your wrist are really close to the surface, so you cool that down, it's going to cool your blood down, which is going in towards your core, cool you down quicker. And then estivation, which is like hibernation, but during the warmer months. Flip side, to deal with the cold, you get more insulation, smaller ears and appendages, and then again with the countercurrent heat exchange works both ways. And then again, hibernation, just pretty nice. I kind of wanted to do some estivation this summer when it's August and it's 1,000 degrees. I just sometimes wish I could take a nap and wake up in October, but I don't have that choice. So here's what I was telling you with the countercurrent heat exchange. So here in this example, these veins aren't close together on the left-hand side. The blood coming from the body is 37 degrees Celsius. It's going out, and as it's going out, it's cooling down. Gets to the end, comes back down, and by the time it gets back to the body, it's 16 degrees. So that's really going to drop your core temperature down. But if you move those veins in closer, as that blood is going out, it's getting warmed up as it's coming back in because the warm blood is right next to the cold. So here it's basically the same. So you're not cooling down as much. And here you can see it's really cool, and it works in the heat as well. So this arterial blood from the heart is 43 degrees Celsius. It goes next to a nasal venous cavity, and so the evaporative from the nasal area is cooling down that blood. So when it gets to the brain, it's only 40 degrees. So his brain's not overheating, and you can deal with that. Pretty cool way critters can deal with the heat and cold. It's always been fascinating to me. So dealing with water, osmoregulation. So water, how do we get water? Obviously just drinking some, find a lake, pond, what have you, and then preformed waters from your food. So think like watermelon or things that are rich in food already. You get that free water from it. And then you have metabolic water. So if you eat something like that's fatty, and as your body's breaking that down, it will turn into water. So those are 3 ways you can get water. Ways we lose water: urination, obviously, evaporation, like you're sweating, and then for the females, the lactation, it really utilizes a lot of water to make that milk. So things we can do to help reduce that water loss is, well, we can't we kind of evolved with it. You can't just like choose to do these things right away, but you know, you lengthen the colon to absorb more water. Think of like horses. You ever see horse stool out in the field? It's real dry, so it tells you they evolved in areas that didn't have a lot of water. So they evolved that large colon to get that water back before they excrete their waste. Think about cows and their stool, or you know, bison. It's real wet, so they obviously evolved in areas that water wasn't that big of an issue. Your urine with more efficient kidneys. There's some really cool like mice and stuff out there that can even drink like salt water and just have such an efficient kidney that they can get that salt down and utilize it that way. Pretty cool. And then lots of sweat glands. Think like pigs, they don't sweat, so they're give and take. You're gonna have to deal with that, but you know you're not gonna lose the water. Locomotions, how the mammals get around, is pretty cool. It's flying lemur, kind of misnomer. It's not, doesn't really fly, it's not a lemur, but it glides around, pretty cool critter. Foot posture, plantigrade, ditchgrade, and ungularate. So we're plantigrade, we walk on our feet, on our foot. Think ditchgrade, dogs, cats, and walk on their toes. I think that would be pretty hard, but to take that one step further, you got your ungulates that walk on their toenails. They're actually on their toenails, and it's basically lengthens their stride. They get taller, leverage, so speed. Pretty remarkable. Just think about walking all day on your toenails. It's pretty incredible, but they do it no problem. Pretty cool. So different. These are your $6 words. Pretty ambulatory critters that are made, that are evolved for walking like we are. We're plantigrade. We walk on our whole foot. Walking around is your ambulatory. Fossorials are running. They adapted to run like dogs and wolves. They can just run forever, right? They're running on their toes. They're built for running. Running is basically like they're walking. Saltatorials like jumping and bounding, like kangaroo. This ricocheting, it's kind of like saltatorial. You're bounding, but you're kind of going back and forth like a kangaroo rat, kind of ricocheting all over the place. Brachiating, monkeys. You think monkey bars, like monkeys in the trees, are brachiating, going hand over hand. It's called brachiating. Volant is flying. Glissant is gliding. Arboreal, climb trees. Like I think we were talking about gray foxes earlier. They're actually arboreal. They can climb trees. It's pretty unique. And then fossorial is digging, burrowing, like badgers, armadillos, things like that. So we have distributions of mammals. How do these mammals get where they got? One way is a corridor, so this allows passage without barrier. The Bering Land Bridge, right, is open. Just walk on, have access to all that area, no problem. And then there's filters, which has a barrier, and if you can make it past the barrier, great, no problems. But so it will block some creatures from doing it. This Panamanian isthmus, which I'll get to on the next slide. But then sweepstakes, this is kind of like a random 1 in a million deal, hurricane, tornado, just kind of a happenstance, not really a way to distribute yourself. But here we go. We have the Panamanian isthmus. It's a tropical forest. So like if you're in North America, want to get down to South America, you got to be able to go through that forest. And here you can see a list that some made it. And there's a lot more barriers now, but if you think about before, when we had all these man-made objects to get through, we still have this forest. And some creatures were able to get through. Like here it says stop by filter. Most of your armadillos and anteaters and sloths and stuff wouldn't make it through. That's why we don't have them here in Texas. And then, but the porcupine, opossum did, and a little bit of list. The bison couldn't make it through. That's just one example of a filter there. Any questions so far? I feel like I'm going a little fast. I can't hear anything, so guess we're good. Thumbs up. Y'all hear me all right? Cool. So,
We're on mute.
what's that?
We're all muted so that
Oh.
you can talk.
Okay, gotcha. Reproduction is a little biased towards bison. I worked at the nature center. I love the bison. Got to work with them, so pretty cool experience. But it's you talking about reproduction here. Sexual selection. So picking a mate. You have selection, male competition. So here we have white-tailed deer, and they're battling, right? Direct competition with one another for access to the females. So they're going to fight. And here we have intersexual selection. So the males are kind of advertising, and the females pick based on this advertising. And these traits are usually not associated with fitness. And this is pretty unique circumstance, pretty cool, I think, is a runaway selection. So here's the Irish elk. It's extinct. It has these massive giant antlers, right? Well, the female's like, hey, I like them, the big antlers you got. So they kept getting selected and selected and selected. And they lived in Ireland and peat moss bogs. So their antlers got so huge that they were sinking, and they weren't able to move around in their territory. So no more Irish elks. So it's pretty remarkable. But mating systems, monogamy and polygamy. Obviously, monogamy is one male partner and one female partner. You have polygamy. You either have polygamy, which is one male with multiple female partners, or polyandry, which is one female with multiple male partners, and then promiscuity, which is both male and female have multiple partners. Also, resource defense polygamy. So male will have resources in this area, and he's basically guarding this area, and the females want those resources, and he defends them. And so they choose that way. And then male dominance polygamy. So male has just a territory, and this is his territories, and he's going to protect his females within that area. And so that's how they choose. And then you have kind of scrambled polygamy, which is basically, think about like mountain lions. Their distribution is so wide and so far. It's just a scramble of who you run across. It's not really happenstance. You know, who you come across is what you get basically. Reproduction pattern. You're monitoring your egg laying. So like we talked about Protheria, your like egg laying mammals, the duck-billed platypus, Echidnas. And then you have your marsupials, which is very short gestation, right? And then extensive development after birth. And then you have eutherians like we are. We have long gestation, variable development after we give birth. So we'll talk more here about this development. I'm doing on time. It's 8 o'clock. I'm doing all right. We have delayed fertilization, and most of this you'll see in bats. Bats are pretty unique. They do migrate. And then we'll see delayed development, delayed implantation, and then embryonic diapause. So we'll deal with those. So I'm not even going to attempt these big, long families of bats, but you can see them there. They have delayed fertilization. So copulation takes place in September, October, right before they hibernate. And then the sperm is immotile, and then it's stored in the uterus. And in the spring, the eggs ovulate, the sperm become motile, and then the fertilization takes place. It's pretty cool. The way you can find your mate and then copulate, and then you don't have to worry about it after hibernation, right? Well, you have delayed development. So in this case, the copulation takes place. You have your bliocyst, which is 200 to 300 cells, and then implants, but the development is very, very slow. So that bliocyst implants, but then again, the development is very slow. And so this is pretty cool because that blastocyst, that ball of cells is implanted, and it's waiting for the right moment to get, hormonal signals. But then they get a lot of insects coming in, things are happening. Let's kick this into gear and get that baby growing. Really cool adaptation there. And then we have delayed implantation. So you have your ovulation, your copulation, and the fertilization occurs normally, but then the development of that ball of cells we're talking about, it kind of floats freely and suspended in the reproductive tract until the environmental conditions become favorable. So like we said, the resources are good, go ahead and implant, and then start that baby growing once we got all the resources available. This is pretty cool. Embryonic diapause, and you can see here in this kangaroo. All right, I'm gonna try to break this down. Let's talk to my wife about this. It's pretty crazy. This kangaroo, okay, she's got 3 different young in 3 different life stages all at the same time. So you have you copulate, you have true gestation, which is obviously very short in marsupials, and you give birth, and that little young attaches to the teat for a very long period of time, 235 days. But shortly after you gave birth, and then that young attached to the teat, you mate again, and so that one's in embryonic diapause. It's kind of just waiting around. And then once that first one leaves the pouch, you give birth to that other one, and it attaches, and then you mate again, and then that one's in diapause. So you have one that's coming and going, you have one that's on the teat, and then you have another one waiting in diapause. So it's pretty mind-boggling to me, but pretty fascinating, pretty cool. And then you can see that this occurs in your marsupials and almost all your kangaroos. Any questions on that? Let's pause here, and anybody's got anything before we get into skull ID?
We do have a question.
All right, what you got?
From Ava. Could you put one of the slides from the very beginning of showing mammals being broken into Protina, Eutheria, etc. again?
Yeah.
Please, thank you.
Oh yeah, no problem. So the breakdown.
Told you it was the very beginning.
Was it this one? Was it this one or?
Yes, yours was much more clear than the book was. Let me just write that.
And so when I was taking mammalogy, this is the book we used. Mammalogy, 4th edition. Oh man, I can't really see it.
Could you show the next screen that showed the Mesotheria and the Eutheria on 2 separate lists, please?
That one?
I think so. You were backing through it and I saw it. Thank you.
Yeah. Oh, I see somebody's got an armadillo in the background. Oh, that's
okay,
Mike.
I got it. Thank you.
All right. Let's see. Go to skull ID. This is my favorite part. So hope you like it too. There we are. Get situated here. Before I get started, this is kind of like a really great book, The Mammals of Texas. It's called Mammals of Texas. David Shimley and Robert Bradley. There's a bunch of different editions. They're all really great. They're just kind of updated on distribution. But I reference this a lot. You know, a lot of people come up and say, you know, hey, what's start talking about some critter, you know, and like, hey, you know, how far to the west do they go? And you just boom, look in here, and it's got, I'm not breaking up, but we got the state of Texas there, and then distribution. Really great book. Highly recommend it.
Hey Nick, I have a quick question for you.
Yep.
Your previous slides that you've been doing, you've had a lot of you know, scanned copies of some not graphs, but pictures and images. Were you getting it from that book there, or what book have you been?
Yeah, I got them from this mammalogy book.
Okay.
Mammalogy 4th edition.
Okay. Thank you.
Yeah. And I can email Mary Beth or Mike and so y'all can get that information as well. So normally I did this before, and I've done other done just skull ID stuff. It's, yeah, a little obsessed with it. I like it a lot, but I really like to see, you know, faces and like that. I like to have them out, but we'll make do with what we have. I kind of started with this picture here. We're going to talk about skulls that you can find around here in the North Texas area. But, you know, I love hiking and just being out in the woods. And this here, I mean, they're kind of hard to find, but here we have a skull. I'm not going to tell you what it is yet. Maybe you may know, but a lot of times just finding them is part of the fun I have, and finding them and then trying to figure out what they are. And then I'll talk about some of these characteristics to look for to kind of help you and point you in the right direction. So I think I already pulled this one up. And y'all know what this one is? Anybody?
Whitetail.
Yep, whitetail. So this is a doe. Obviously, they have antlers. You know right away, but the doe doesn't have antlers. Female. Things to look for here on the whitetail deer. It's an herbivore, and what we have, this area right in here, is called the diastema, and it's a big, large gap between your incisors and your premolars, and so this helps with their food manipulation. You know, they have to break down the vegetation. We talked about the cell walls. It's hard to break down, and so this gives them more area in their mouth to kind of manipulate that and chew it up. And another thing here is we have on the lower jaw. Look how high this is called the mandible condyle, or the head of the mandible, right back here. And see how much higher it is than the teeth, way up here, right? So what this does, hold on a second. Can y'all see that all right? Kind of coming in and out.
Since you have a background on, it makes it difficult to see it sometimes.
Yeah. Let's see if I
Kind of greening, it's disappearing and reappearing.
Let's see if I can get rid of my background.
Go down to the stop video arrow, and it should give you the option under there.
There, you can see my office now, so it's all right. It's not as cool, I guess. Let me get out here. There you go. Okay, let's try this. So with this being way up here, all the teeth, they coming down all at the same time. See that? All at the same time, and they're grinding. This will become important later too when we talk about carnivores. So get a lower jaw. You see this way up here, you know it's herbivore. Also, we talked about that selenodont dentition. These ridges run in line with the jaw. An indication, especially around here, is probably going to be a whitetail. Large eyes, predator, or these are prey. So either side of the head, not looking forward, right? Pretty whitetail deer everywhere, common, really common one to find. Find them all over the place. Next one up. What you guess is what you got?
Opossum?
No.
It's a cat. Raccoon.
Javelina?
A dog.
Right. Oh yeah, man. See, we don't have size comparison. Here, I have it right here.
Raccoon.
Yeah, it's raccoon.
A raccoon.
Yep. So, yeah, I'm really struggling with this virtual thing, so you have to bear with me. But so raccoon, what's the first thing you notice, or at least I noticed, is a large brain cavity, right? Huge brain. Raccoons are obviously very smart. They get into everything, right? Especially you birders out there, you get in all your bird feeders and stuff, they're just wreaking havoc. Large brains, dead giveaway, right? Raccoons, they have They're omnivores, they'll eat anything. You can see this, the bunodont that we talked about, the dentition, omnivore. They're not real large canines, but that large brain is going to be your giveaway. Raccoon. Good job. So what's our guesses here? Let me see. Get some size comparison. It's this big.
A possum?
Yeah.
Yeah, I can tell by the eyes.
Yeah. Yep. So possum. One thing with possum is all the teeth. They have more teeth than any other mammals. Lots and lots of teeth. So they're going to use this to try to get you not to eat, or not like coyote. They're going to show all their teeth and say, you better stay away from me. Lots and lots of teeth. And the poor possum has the opposite problem that the raccoon has. Very, very small brain cavity. But you know, he's doing all right. So, and this area on top here, it's called the sagittal crest. And he does have quite a large sagittal crest. We'll talk about more on this later in other critters. But this allows for muscle attachment. You'll notice it on dogs and stuff. So long, strong bite with all those teeth. So those are things to look for in the possum. What do we got next? Any guesses on this guy? What do we notice? We have
Squirrel.
no.
Squirrel.
Close.
A beaver?
No. This, oh yeah.
Rabbit.
Yeah, it's a rabbit. Yeah, I think I heard it. Rabbit.
That's a rabbit.
Yeah, eastern
Pick
cotton.
his size.
Yeah, eastern cottontail. So we have that. We knew right away. We could see that area between the incisors and the teeth, that diastema. That's a giveaway for an herbivore. Obviously, this high mandible head allows those teeth to come all down the same. But the main giveaway for a rabbit is, you can see in the picture, the upper jaw has double incisors. You see those incisors directly behind each other in the front. And this adds support to those incisors, but they're basically doubled up in the front. That's an indication of your rabbits. And on the rostrum, their nose, they have that kind of lattice work, kind of honeycombed a little bit, and make it lighter, faster. That's your rabbit. Here we go. I think someone just said it on this one.
A beaver?
Let's see.
No, oh, that's super tiny.
Yeah, it's a little small. Somebody
Squirrel.
said
Squirrel.
Yeah,
Squirrel.
definitely a squirrel. And so I'm not going to get into all the squirrel is a large rodent, fairly large, not like a capybara or something, but squirrel is obviously very common. Large incisors, very rodent-like. And that's the one thing with skulls. Once you see them a lot, you'll just kind of know it because of the way it is. You can't really describe it. You see a bunch of them, and you're like, okay, that's this. I can't really tell you why, but it is. And then with rodents, there's so many rodents, especially when you get down to like mice, and you're really having to look for skull identification. You might get it down to a rodent, you may just get it down to rodent, or you might get down to family, maybe genus, but it's really hard to get it down to species. But you're really starting to look at teeth, you're taking measurements and things like that. But all your rodent skulls are pretty much going to look the same, and then they're going to vary in sizes versus squirrel, mouse, rat, things like that. So good job on that one. This one, they can be huge.
Or
Yeah.
pig.
Yeah. They get, obviously we have tons of them around here. So here they are omnivores. You can see they have the tusk, your abundant dentition. This is a fairly easy one to recognize. I'm not going to spend a whole lot on it, but one thing I will note is that on this forehead here, it's nice and straight. And so the thing about feral hogs, the closer you get to domestication, so you're talking about your pigs that are domesticated, they'll have like a real flat, pronounced forehead. It goes like that. You'll see it in dogs too, and I'll show you a coyote. Coyote, real nice, hair up straight like that. When you start domesticating, you come and get a forehead. Think about like a pug and bulldogs and stuff like that. You have that raw, short, stubby nose, and that's just caused through breeding and domestication. And pigs, so we have some domestic pigs that escape, and 3 or 4 generations, they'll even start to lengthen that and straighten back out. And you're talking about surface area, more surface area for sniffing and smelling and rooting and things like that. So good job. Easy one, easy one. Here we go.
Gar.
What is that?
Alligator gar.
No.
Armadillo.
We're only doing mammals. Armadillo, yeah, got it.
Yellow, yeah.
So this is, what do we notice about the teeth here? They're all the same, right?
And tiny, super tiny.
Yeah, but they're just eating grubs, and notice that the eyes are pretty much non-existent. They're all smell, right? They can smell like 3 feet under the ground. And then they're just like grubs, worms, you know, things that are easy to break down. So they don't really need a complex dentition. But that one's a good one. That one's I don't see. Yeah, I don't know if y'all are into collecting skulls or finding them, but I don't really see a lot of those. They're few and far between. They're scale-like skin, I think. They break down easy. All right, next one up. This one here.
Yeah.
Yep.
Cat?
Definitely. So this is the cat. It's a predator, eyes facing forward. And with cats, to me, you see that bottom picture there, they're very round, right? Very round, big eyes. And then they have the opposite of the possum. They barely have any teeth, very few teeth, like 28. And possum had like over 50. So not very many teeth. Or the syncodont that we talked about, the carnivore teeth, very sharp, large canines.
Is that a domestic cat or a bark cat?
This is a bobcat here. Yeah. So I really got into cleaning skulls, and you can kind of see probably from my pictures and my progressions that I've gotten a little better at getting them cleaned up. It was quite a bit of learning curve, but and then I can tell you some horror stories about some of the critters that I had to clean up. I won't get into all that. It's pretty gruesome.
I've heard a good way is to put them in an ant bed. Is that true?
Yeah, I've done that, and it does work. It actually works fairly well. But you have to, one thing with that is if you leave it, some critter will walk off with it. So you have to make sure to put a cage on it or a bucket over it, and you got to worry about things. But yeah, that will work. Let's see here. Bobcat, really cool. One of my favorite skulls. Next one here. So this is about this size.
Coyote? Very nice and warm.
Coyote?
Coyote.
Coyote?
So this is a coyote skull, and it's going to look just really like if you have a Labrador, dogs like that, it's almost the same, but what you'll notice is this straight, and then on your lab, there will be a little dip down here where they basically have forehead, and when you pet your dog, you'll notice that kind of forehead right in here, but not on your coyote. On straight, they need all that surface area they can get. Obviously large teeth, very canine, very dog-like, I don't know. Looks like a dog, so fairly easy one. So I don't have one of these, unfortunately. This is a picture I got from the Nature Center. But it looks similar to the one we just had, so that might give you a hint on.
Fox?
Yep, that's a fox. And so this one is a red fox. I want to point at my screen to show you, but I know y'all can't see it, so it's weird. Yeah, this is a red fox. It looks like a small coyote. It's about the size of a raccoon. But notice the genus and species is Vulpes vulpes. And so pretend that this is a...
You can move the cursor and the arrow will...
Oh, yeah. Oh, cool. Yeah. I can see that. So like here, like this is a V, like Vulpes. And then on the next one I'll show you, and these are about the size of a raccoon. But the difference is they do have a large brain, but not as large as the raccoon. And their teeth are purely carnivore, not like a raccoon will have your omnivorous teeth. So that's how you can differentiate. Oh, and I forgot to show you on the coyote, on the jaw here. You see this? Remember on the predator or on the herbivore? It was way up here. Now look, this is right in line with the teeth. And so now then, when I close the jaw, it basically comes in line, and that those scissors actually are just cutting the teeth. So that's, instead of coming down all flat at once, it's actually creating a cutting motion. And so that's important to your carnivores. Obviously, they want to cut that meat down. So this is the red fox, and here we have a gray fox. And notice the genus and species is Urocyan is the genus, and you notice right here is U is the U. So they're about the same size, but that U is dead giveaway. Gray fox, real common. Not common that you'll find, but more so than the red fox you'll see. And this is kind of like we talked about, the sagittal crest forms a U, giveaway for gray fox. Here we have all the cadence. Coyote here, red fox here. You got Vulpes, V, and then the Urocyan right here. So that can kind of help you out there. Any guesses on this one? Let me see. Got one here. Now, little guy, pretty cool. Lots of teeth. Any guesses?
I want to say ferret, but I know that's wrong.
Ferret, that's a good guess. This is a
something in that.
Skunk?
Yep, skunk. So, yeah, this is the one you want to watch out for when you're cleaning it too. But notice here on the back of the skull here, I kind of call it like a hood. It swoops down in the back, and then you have this little lip, and that's common in your mustelids and skunks. But they're omnivores. They eat a variety of diet. They do have your large canines, but the omnivorous teeth, not like a carnivore. Skunk there. What do we? Let's see. So about this size here.
Beaver.
No, I tricked you. What's the other one?
Nutria?
Nutria, yeah. Put the nutria first because everyone would naturally say beaver, because I would say the same thing too. But once you notice the difference, it's pretty glaring.
Why do they have orange teeth?
That's iron. It's to make them stronger for chewing vegetation and stuff like that. And they're ever growing. They never stop growing.
Like rabbits.
Yeah, so that tooth actually goes way back. What's that?
Like rabbits. Rabbits keep growing too.
Yeah, and so and you think about rats and mice, and they're chewing on everything because they
rabbit.
Yeah, rabbits. Yeah, they never stop growing. They're always chewing on things. But the big difference between the nutria and the beaver is this is called the infraorbital foramen. And it's right before the eye, and it's giant. You think this is the eye socket, but the eye socket's really right here. This is a giant hole, and that's a dead giveaway for a nutria. But if you just find the lower jaw, on here, you can see better maybe in the camera. This flares out at the bottom. The lower jaw flares out, and then I'll show you here. That's the nutria, and then here this is the beaver. So that same infraorbital foramen is right here. It's tiny. Dead giveaway. That's the beaver. The eye socket's back here. And then on the lower jaw, it doesn't flare out. And then, I don't know if you can see the teeth. Those ridges run transversely. It's your lophodont dentition. Another way to help you start IDing the skull. And then this next picture, I got them side by side. And when you know what to look for, it's dead people. There's that infraorbital foramen, and then just this little guy right here. But they're big skulls, beefy skulls, the big large teeth. And here, so I actually have one here. The best way to get my skulls, if you're interested, is find an owl, follow it around until it vomits an owl pellet, and then dig it out. It's super cool. It's great with kids, and they come out clean too, and they're really cool. But yeah, this is a deer mice. Really, really cool way to get those. But it's, you know, it looks like the squirrel but smaller. And then the rodents, they're really tough, really, really hard to identify. But at least you know it's Griffin. And here I kind of wanted to put next to a raccoon and a gray fox, so you can see that they're similar in size. But you know, raccoon has large brain, doesn't have that U on the top, and then the teeth, right? That fox is a carnivore, where the raccoon's an omnivore. But you can easily get mixed up with those two. Appreciate y'all having me. Y'all can email me here if y'all have any questions. Appreciate it.
I'll read some questions from our chat. Do skunks belong to the weasel family?
Yes. Well, they've done a little bit of switching, but your mustelids, look into that.
They want to know, how do you clean skulls and do you ever boil them?
Yeah, so I've done a lot of different things when I was an intern, messing around, and but if there's a guy on YouTube, and he's got a YouTube channel called White Bones Creations, and I've kind of been following him, and so my preferred method now is, the best thing to do is find them fresh, but obviously you don't always have. If you're just out in the woods, it may not be fresh, but you want to remove all the skin, as much flesh as you can. I'm getting some great reactions, but and then if you have access to a power washer, that's the way to go. And you want to suit up for this, I'm telling you, because there's going to be things flying everywhere, and it's pretty gruesome. Wear a mask and some clothes you don't care about, but you want to get as much as that meat and flesh off of it as you can, and then you're going to boil it and do it again. And once you boil it, that flesh is going to come out, and then it looks really good after that. If you really want to take it to the next level, you can get some hydrogen peroxide, especially like your pool grade, some like higher. Be careful with your higher percentages, because it's pretty nasty stuff, but you want to dilute it like 1 to 3, and then you want to put it in there for like a low boil, get it up to boil, and then shut it off, and then it really sparks like this bobcat is one I did like that. It's super white, and you can go the natural look too.
Sweet, thank you.
Yeah, I could talk about that for so.
One more question. How can you distinguish between cattle and bison skulls?
Oh, that's a good one. Bison skulls, I wish I had two side by side, but the horns are going to be a pretty good indication. The bison skulls is pretty wide and flat on top, and you have those iconic bison horns, so that's probably going to be a good way to do it. But as far as your lower jaw and your teeth are going to look really similar, so couldn't really help you out right there. And then there's obviously a lot of different species of cattle, Angus and Jersey cows and things like that. They're going to look a little bit different, but I'd start with the horns of a bison.
Two people are wanting to know about advanced training. So you whetted their appetites and they want more.
Oh, I guess that's a good time.
Specifically with identifying and cleaning skulls.
Okay, yeah, let's do it.
Okay. Thank you so much, Nicholas. And a lot of comments complimenting you on what a great presentation this was, and how enjoyable and enlightening it was.
I appreciate it, guys. I hope I didn't do y'all disservice. I enjoyed it.
So I guess we're going to turn it back over to Melinda.
Melinda.
Hi,
Melinda.
Great, thank you.
Thank you, Nick. That was
Hey.
really wonderful. It was a great presentation.
Thank you.
Anybody have anything else? Do we still have Michael Perez on?
Which one?
Well, I guess I'm looking for
Ralph?
the one that looks like you're in an underground layer of some sort.
I'm a bison.
There you go. Oh, wow. Okay, I see that.
I'm here.
Anything else before we go about anything? Again, thank you so much, Nick. That was
Yes.
great. And without you guys doing these presentations, we couldn't do this. So I really appreciate you taking your time out and
Melinda, may I interject a question? I deeply apologize for interrupting, but I wanted to ask Nicholas what the legalities are regarding skulls found. Are there any?
Yeah, that's a good question. In general, you're not going to have an issue because there will be proof that like it's been around for a while. But like Mike will probably tell you, like with bird feathers, it's a no-go. But with skulls, you're going to have to really, especially pay attention to like your game animals. But as far as your non-game animals, and you can look at your Parks and Wildlife regulations and get into that. But for the most part, if you have an old beaten down skull, it obviously hasn't been freshly taken. I wouldn't see a problem with that. And again, I'm not a game warden, so that might be a better question for them.
Thank you very, very much. Sorry again, Melinda, for interrupting.
No, it's fine. Anybody else have any questions for Nick before he goes?
Yeah, Nicholas, are you going to put together an advanced training for the identifying and cleaning skulls? And if you do, are you going to email us or what?
I guess I can do that. Let's do it. Let's get the power washer out, right?
Sweet. Let's do it. I got a boar skull that's been waiting for years.
Okay. Yeah, I'll get with Mike, or he can get with me and Mary Beth, and we'll work something out.
Okay, great. Thanks.
Awesome. Yeah, we won't turn that away for sure. I enjoy it. That's great.
I think I need to get the possum skull out of the creek.
Yeah. Bring them on.
Well, Melinda, I didn't really have much to say. I just want to again thank Nick for doing it. And as I told y'all, you're going to enjoy him. He's very knowledgeable. He has a great demeanor and he's a great presenter. So thank you again. Also want to mention next week, we're going to be talking about the prairie. So we're going to go into our third system and talk about the prairies. So our speaker is a former staff member at the Nature Center, Michelle Villafranca. So she'll be talking about the prairie system. I don't have my Master Naturalist book in front of me, but go into to the table of contents, look up prairie, and just check in on that chapter. She's quite passionate when it comes to the prairie. She invests a lot in the prairie on her personal life and also work related. So she really loves the prairie. So you'll definitely see that. So that's what we'll be talking about next week. Once again, field trip Saturday, Refuge Center, where we met last time, 9 a.m. Bring all the things like water, sturdy shoes, insect repellent, things like that. And then just
Bring
like
the money you found at the wastewater treatment plant. That was for glory. You didn't
Yeah,
hear
I will
that, did
do
you?
that. I will be sure to bring some.
Are we going to be walking through any water? Do we need to bring any shoes that are water resistant or such?
Again, bring your mask, and we'll do our best to social distance ourselves as well as and learn as well. So that's really all I have, Melinda. So
Okay, just a reminder, if you know you're not going to be there, let us know as soon as possible so we can plan for that. And you can text me You guys all have my phone number. Anytime you need to get a hold of me and I'm not answering my email right away, or because I do get a lot of emails, so please don't ever hesitate to give me a call or send me a text, because I'm more than happy to get back to you. And it's usually the quickest way to reach me is a text message will do great. So let me know if you can certainly text me and let me know if you're not going to make it, and I can pass that on. And then we can start figuring out what sort of opportunities there might be out there for makeups. But the field trips are kind of hard to make up sometimes. The aquatics trip, there were some opportunities that it didn't seem to be quite as difficult, but some of these other trips are, it's really important to be there if you can, because we have some really great instructors that are spending their Saturday out there helping out, and they do a really great job. And some of those field trips, it's a lot to get those things made up. So let's, if you guys can make it, please try to be there. But if you can't, things come up, I get it. Just let us know, and Dawn can be looking at some opportunities to possibly get that requirement taken care of. So anyway, anybody have any questions for me or anything before we leave?
I do.
I guess prairies next week. So let's, if you get a chance to get a nice little prairie picture, some sort of prairie related photo for your background, that'd be fun. Okay, I'm sorry. And who said something?
Oh, I had a question.
Yes.
I didn't go to the last field trip because I was out of town. Where are we meeting?
It's at the service center at the Fort Worth Nature Center. So you go in through that main gate